Hello everyone, myself Meeha, Assistant Professor from in the Department of Information Technology from Tech Multitech, Dr. Rangarajan, Dr. Shakuntala Engineering College. So today we are going to learn about GSM. So what is GSM? GSM is a global system for mobile communication. So in the earlier, we only follows analog. And when you're using analog, there is a lot of cons. Comparing pros, we have a lot of cons. So that we develop GSM, Global System for Mobile Communication. So in the early 1980s, there were analog technologies. For example, the analog technologies itself developed in European countries in the earlier stage. So first one, advanced mobile phone services. It is developed in North America. So advanced mobile phone services, it works only in a certain boundaries. It doesn't have, you can't send messages, only calls will available, voice calls are available. And there is a lot of threats in security. So advanced mobile phone services. Then in UK, they follow total access communication system with the same features what we have in AMPS. Then Nordic countries such as Norway, Sweden, and then Ireland, Finland, such countries follow Nordic mobile telephone. All these systems work only within a boundaries of each country. The mobile equipment manufacturers markets were limited by the operating system, and all this uh, analog technologies only send voice calls. It doesn't receive any SMS or anything. Okay, so this is the earlier stage. So considering all their disadvantages, the solution was GSM, which is digital technology and developed by Conference of European Post and Telecommunication. So the goal, why we developed GSM? The goal is it has high speed quality, low cost mobile sets and base station, support for international roaming. So it earlier started in European countries. So one system for all of Europe, support for range of new services and facilities, compatibility with ISDN and other telephone company services, enhance privacy, security against fraud. So considering all this goal, GSM is called as second generation system. So this is a system architecture. So it hardly contain three parts. First part is mobile station, second one base station subsystem, and third one network subsystem. So in mobile station, this mobile station is nothing but a mobile equipment, and it has two entities. One is mobile equipment, another one is subscriber identity module. For example, your mobile phone is a mobile station. User, you are using mobile phone, your mobile phone is a mobile station. Yes, mobile equipment that is manufactured by different manufacturers, and then you have SIM. Okay, the identity, it has specific IMEI number. So IMEI number, we know, right? Every phone of us has a separate IMEI number. If we lose our phone, we can track using IMEI number, right? So IMEI number is called International Mobile Equipment Identity. And mobile transmit and receive voice at 13 kbps over ear interface from this mobile station. Okay, and then next one, so that is mobile station. Second one is base station subsystem. Base station subsystem. So what is base station subsystem? It has two, BTS and BSC. So what is BTS? Base transceiver station, and what is BSC? Base station controller. Okay. For example, if a faculty need to say something to a student, we pass the information through the student representative, right? Say if the mobile station from mobile phone, if I want to reach the tower, I will go through BTS, that is base transceiver station. Okay, now what is mobile station? And then this is a mobile station, like continuation of mobile station. we have subscriber identity module SIM, right? So in the SIM, we have serial number, subscriber key, subscriber identity, everything. Then SIM features and context are personalized by the service activator, protected by the password admin. MS also stores some temporary data on SIM during operation. The next one's base station subsystem. Okay, so you can see in this picture base station subsystem. So it contains two interface, like one is BSC, another one is BTS. What is BSC? Base station controller. And what is BTS? Base transceiver station. Okay. Base transceiver station. House the ratio transceivers that define a cell, transmits and receives voice at 13 kbps to mobiles, commands mobiles to set TX power and handover. So what BTS do means, BTS is a small towers around our home. Okay, around our area, small towers. So, okay, each BTS, there is a rectangular hexagon shaped cells are there. So each cell have one BTS. Okay. So this BTS get the signals from our mobile station. And then this BTS passes the signal to base station controller, that is BSC, base station control. Okay, look, several BTS are connected to one BSC. BSC managed channel allocation, handovers. What is handovers means? You are traveling from one location to another location. When you losing the one BTS, it give the connections. The BSC monitor it and give the connection to the nearest BTS. Okay, which is controlled by the same BSC. So this is what BSC manages, and channel allocation, handovers, and release of channels of connected BTS. BSC connect to each BTS on ABIS interface and to MSC on A interface. BSC has the entire database for all cell parameters associated with the BTS. The next one, mobile switch center. So what is mobile switch center? So when you call BSC is a brain of GSM, then MSC is the heart of GSM. This MSC control all the BSC. MSC comes under network subsystem. So this MSC control all base station subsystem, also mobile station. So all this controlled by mobile services switching center. Okay, so this mobile services switching center exchange where the calls are established, maintained, and released. It contains database for all the subscribers and their associated features. Communicates with BSC. It communicates with base station controller on mobile phone side, that mobile station side, and with the PSN on fixed line side. So this mobile switching center mainly focuses on three jobs. So one is control, that is connect, collect, and supervise. These three jobs are done by mobile switching center: connect, collect, and supervise or monitoring. It connects calls from sender to receiver using base station subsystem, and then it collects details of the calls made and received. It supervises the operation of the rest of the network components. So these are the jobs of uh, MSC, mobile switching center. And then next one, home location register. Okay, so what is home location register? So home location register means when you are going to home or coming college, you have a register, right, to monitor when you come in, out. So these are called home location register, right? Home location register. So like this, we have home location register. It functions or the MSC has all subscribers database that's stored in HLR. Okay, so HLR, home location register, it contains all. Whenever you are making a call, the home location register, it has all the database regarding which related to that specific call. So that is HLR. HLR has all permanent subscribers database. MSC communicates with HLR to get the data for subscriber on call. HLR will have the series of all subscriber numbers which may not be activated or issued. Then next one, we have visitor location register. So this home location register and visitor location register, we have difference. Home location register, it has the data of like permanent subscriber database. If I am in Tamil Nadu, these Tamil Nadu people's all the data will be there in HLR. So VLR is visitor. Whenever someone is coming from some other state, the VLR register has these their datas. Okay, then the MSC communicate with HLR for subscribers coming from different MSC and it found valid, then registered them, it's into VLR. Okay, so first the MSC home location register means it's a calls that made in sorry, like for example Tamil Nadu. Okay, now some person is coming from other state, so now the MSC will verify with the HLR. Now if their database was not in the HLR, now this person, this visitors database will be automatically stored in visitor location registers. Okay, and then they monitor, they follow, they monitor them and they follow them. Okay, next transcoded rate or rate adaptation unit. So TRAW converts the data rates between 12 kbps GSM rate to 64 kbps standard ISDN rate and vice versa according to the calls, according to the ISDN or SDN, it the data rate, the frequency will be changed. And then next one, authentication center. Okay, so authentication center is a process by which a SIM is verified. The SIM is to verify a user to avoid a fraud or threat. Okay, so that is authentication center. Secret data and the verification process algorithm are stored at AUC. AUC is the element which carries out the verification of SIM and it associated with HLR. The next one, equipment identity register. Okay, equipment identity register is a mobile equipment database which has a series of IMA. MSC asks the mobile to send its IMA, then MSC then check the validity of IMA with EIR. All IMEA are stored in EIR with relevant classification. The classifications are whitelist, blacklist, and graylist. Okay. So whitelist. What does whitelist means? The SIM has, the mobile station has no issue. They allow the call and they receive the call, everything. The second one, blacklist. Blacklist means it's a fraud and it is a threat. So it won't allow that types of calls. Then gray list. What is gray list means? It is a suspected one. Okay, so we will allow it and monitor this. This is called 3 classification in EIR. The next one, so GSM operation. So what is GSM operation is? So this which mean GSM speech transmission and reception process. So this diagram explains the transmission and reception process of GSM. Speech transmission and reception process of GSM. So first the speech coding. So what is speech coding? When the call comes, when the mobile station itself, the audio will be converted, the audio analog signals will be converted in the digital bits in the speech coding area. Then it comes to channel coding. Channel code, the work of channel coding is it add error correction and it remove the noises. And then interleaving. So what does interleaving means? It convert digital bits into radio frequency. Okay, and then interleaving and then ciphering. It converted text to this encryption will be done in ciphering and then modulation. So what modulation means? It converted the digital bits in the radio frequency and then transmitted over the air interface. Now it comes to demodulation, then deciphering, that is ciphering and then deciphering. Okay, then de-interleaving and then channel decoding same as there, if there is any, all that noises will be added. So channel decoding and then speech decoding, same. Now the digital will be transmitted to the analog. So this is the GSM operation. And then frequency resources, all the calls made have uplink, downlink. Okay, which is up means empty, which is mobile station to BTS. Downlink means uh, BTS to mobile station. So this is uplink frequency and downlink frequency. So uplink frequency, for example, if uplink frequency is 900, then it will add with 45. Then 45, then it will transmit it to, again it will receive to mobile station. For example, if its uplink is 900, then the downlink is 945. Then that is duplex interval. The bandwidth of uplink and downlink is 25 megahertz. When you calculated both, it comes 50 megahertz. Then one channel carrier frequency is 200 channel. When you split it into, it have multiple channels. Each channels have 200 kilohertz. One guard band at 200 kilohertz. Then access technology. So after access technology is first generation, second generation, and third generation. So for first generation, we use a separation in frequencies, only separations in frequencies. But in second generation, several users share the same frequency. You can see in the diagram, the first diagram, users separated in frequencies. So it's very low. When you reach, it takes times, low quality. But in second generation, we use as GSM, right? So in GSM, the frequency is too high. Each channel we have 200 kilohertz frequency, which means several users share the same frequency, but separated in time. In practice, combined with FDMA. Okay. So time division, multiple access we are using in GSM. Then advanced from GSM, that is third generation. We are using CDMA 2000 and WCDMA in the diagram. We use code division, multiple access. Many users share the same frequency at time. You can see the diagram, right? Many users. So for example, 1, 2, 3. In the 3, it is a broad, right? So many users can use a same frequency and time in third generation. Then FDMA. So what is FDMA? The base station can receive signal over a continuous range of frequency. So that we call spectrum. Now this band is divided into many small carriers, that is called subbands. So in FDMA, we assume that the base station can receive radio signal in a given band of spectrum. That is a range of continuous frequency values. The band of frequencies broke up into smaller bands, that is called subband. Each transmitter transmits to the base station using radio waves on its own subband. So you can see here the total frequency divided into several small bands called subbands. So cell phone user 1 using one subband, cell phone user 2 using subband, but the whole full band, spectrum band is divided by subbands. Then FDMA. The continuation, the subband is also a range of continuous frequency. When a user is assigned a subband, it transmits to the base station using a sine wave with a sender frequency in that band. When base station is turned to frequency of a desired user, it receives no portion of a signal transmitted by another inside user. This way, the multiple local transmitters within a cell do not interfere with each other. Then TDMA. So now TDMA, on pure TDMA base station does not split up into allotted frequency band into a smaller frequency sub. Rather, it communicates with the user one at a time. So in FDMA, many users can talk, right? Each have subband, so there is no collision. They can speak freely, but in TDMA, only one user at a time. That is, we call round robin access. That is called TDMA. Then handoff. Then handoff is a main topic. What is handoff? Say a person is traveling from one area to another area. So he comes under one BTS, right? Now he is traveling from one BTS to another BTS. When he ended one BTS, when he in the situation of ending one BTS, there will be some signal issues. These signal issues will be monitored by our MSC. Okay, now MSC monitor the signal issue, and automatically the signal issue will be solved by connecting the upcoming BTS. Okay, when it comes closer to the second BTS, the MSC will order the BTS to take over the signal, take over the particular signal from BTS 1 to BTS 2. So this is called handoff. Okay, when a mobile moves into a different cell while a conversation is in progress, the MSC automatically transfers the call to the new channel belonging to the new base station. Handoff operation: identifying a new base station, reallocating the voice and control channel with the new base station. Handoff threshold: minimum usable signal for acceptable voice quality is 90 dBm to 100 dBm. Handoff, we have some margin. Cannot be too large or too small. If it is too small, large, unnecessary handoff burden the MSC. If it is too small, there may be insufficient time to complete handoff before call is lost. The next, suppose a user is transmitting and receiving a signal from given base station, that is B1. Assume the user moves from B1 to B2, coverage area of one base station, into the coverage area of second base station. I already told, right? BTS 1 to BTS 2. Now the BTS 1 notices that the signal from this user is degrading. Now the BTS 2 notices that the signal from this user is improving, because he is coming inside the BTS 2. So the signal from this user will be improved. Obviously, it will improve. That BTS B2 notices that improving, so it takes care of it, hand of it. At some point, the user signal is weak enough at B1 and strong enough at B2 for handoff to occur. Specifically, messages are exchanged between the user B1 and B2 so that the communication to from the user is transferred from B1 to B2. So this is a diagram. Okay. So first BTS, now it comes under end. Now BTS 2 will be take care of mobile. This is the numbering arrangement. So in the whole system of GSM, we have few secure numbers, right? For example, for mobile device, we have IMEA. So the IMEA totally contain 15 digits. The 15 digits will be split into TAC, FAC, SNR, and SP. So TAC is model ratification code, 6 digits. Okay. And then that is a model of that. For example, in which model this mobile, which manufacturer that. Then FAC is the factory assembly code, 2 digit. Then SNR is a sequence code. It has 6 digit, and SB reserved 1 digit. Then IMSI, International Mobile Subscriber Identification Number. Okay. So this IMSI is written into the SIM card by specific device and software, and we stored in the HLR with other user information. So it also contains MCC country code plus MNC network code plus MSIN subscriber identification, the 10-digit mobile number. So 15 digit totally. Then next one, mobile subscriber ISDN number, MSISDN. It is the subscriber number commonly used to CC plus ND. CC is our country code, NDN is the network code, and SN is the subscriber number. So this is what. So thank you. So this is the GSM. So GSM is the procedure. Why we develop means for the continuous call without interference, security, everything considered, we build a GSM. With GSM, we are only because of GSM technology. Today we developed a lot of things in the GSM, a lot of things, but in the first time, the GSM only gives some ideas for the advanced technologies and all. So GSM, once again, the architecture, this architecture now also we are following, right? So when you are going out, there are many small towers that called BTS, which is controlled by base station, and the base station controlled by one MSC, mobile switching center. This mobile switching center only provides security to the call center. So this is called GSM. global system for mobile communication. Thank you. Thank you so much.